You are watching AliAziz Quality Education YouTube channel.
Materials and Hardware, in BSc Aircraft Maintenance Engineering Technology, AMET, by AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry-related videos. So don't forget the subscription button.
Aircraft are highly engineered machines that demand the use of specialized materials and hardware to ensure strength, durability, safety, and performance. In the Materials and Hardware, subject, students are introduced to the fundamental materials used in aviation and the standard hardware components applied in aircraft structures and maintenance. This subject builds the foundation for understanding the mechanical properties of materials, their applications in aircraft, and the correct use of fasteners, joints, bearings, and other hardware components. Objectives of studying aviation materials and hardware, To understand the types and properties of materials used in aircraft. To study corrosion prevention and material protection methods. To learn about standard aircraft hardware components, bolts, rivets, nuts, bearings, etc. To develop practical knowledge of material testing and selection. To ensure correct maintenance practices and compliance with aviation standards. Main topics covered. 1. Aircraft materials. Ferrous metals. Steel and its alloys. Heat-treated steels for strength and durability. Non-ferrous metals. Aluminum and aluminum alloys, widely used in aircraft structure due to lightweight. Titanium, high strength-to-weight ratio, corrosion resistance. Magnesium alloys, lightweight applications. Composite materials. Carbon fiber reinforced plastics, CFRP. Glass fiber and Kevlar composites. Advantages: weight reduction, fatigue resistance, high strength. 2. Mechanical properties of materials. Strength, hardness, ductility, and toughness. Stress, strain, and elasticity. Fatigue and creep in aircraft components. Material selection criteria in aviation. 3. Corrosion and protection. Types of corrosion: surface, galvanic, stress corrosion. Causes of corrosion in aircraft, environmental factors, dissimilar metals. Protective coatings, paints, primers, anodizing, plating. Corrosion inspection and prevention practices. 4. Aircraft hardware. Fasteners. Bolts, screws, nuts, and washers. Locking devices, lock nuts, safety wire, cotter pins. Rivets and special fasteners. Solid rivets, blind rivets, high-lock fasteners. Riveting techniques in aircraft structures. Bearings and bushings. Ball bearings, roller bearings, plain bearings. Applications in control systems and engines. Pipes and unions. Aircraft hydraulic and fuel lines. Pipe fittings, unions, and seals. 5. Material testing and identification. Destructive testing, tensile, hardness, impact. Non-destructive testing, NDT ultrasonic, eddy current, magnetic particle, dye penetrant. Identification of aircraft hardware using standard coding, AN, MS, NAS standards. Importance for AMET students. Provides fundamental knowledge for maintenance and repair of aircraft. Essential for understanding why specific materials and hardware are used in different aircraft parts. Builds practical awareness for licensing exams like EASA Part 66 or CAA AME licenses. Helps prevent structural failures by correct selection and use of materials. Career relevance. Students with strong knowledge in materials and hardware can work as aircraft maintenance engineers, mechanical/structures. Quality control and inspection officers. Aircraft material testing and NDT technicians. Aerospace manufacturing and production engineers. Conclusion. Materials and hardware, is a crucial subject in the AMET curriculum as it connects materials science with practical aircraft engineering applications. A deep understanding of this subject ensures that maintenance engineers can select the right materials, use hardware correctly, and maintain the structural integrity and safety of aircraft throughout its service life.